Hello folks, this time around we'll get into playing with functions in Bash and then we can start doing some more interesting stuff. The concepts are pretty similar to functions in other languages. We will see a little bit of unusual handling in terms of the return values and the output of functions, but we'll come back to that in a few minutes. Most common syntax for defining a function is simply to use the function keyword, so say something like function foo, and your open and close round brackets for your parameter list. Now, we don't actually list the parameters in here, and I'll talk about that in just half a second. The open curly brackets, I've stuck it on the same line here, but you can quite happily put it on the start of the next line. Local is the keyword to identify variables that are local to the function, otherwise they're going to be global variables as well. So whatever the body of the function happens to be. Now, in terms of the parameters, again, you don't list them when you're defining the function. Functions can be called with any number of parameters, and it's basically, again, you think of the idea of things being used from the command line. On the command line, the user could type in any number of things, and somehow the function has to be able to deal or not with whatever it gets passed. So the function doesn't have a list of expected parameters, and again, no types because everything's a string pretty much. The way we get at the parameters within the function is through these special variables $1, $2, $3, etc., 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 that refer to them positionally. So $1 is the first argument, $2 is the second, $3 is the third. If you use $something or other and that argument wasn't passed, there weren't that many arguments, then it's just going to be a null. So we can use it this way. $0 is a special that will give you the name of the function back. So we will play with this a little bit. So this is saying, okay, if we were expecting here the user to pass two arguments, two parameters, and we're just going to print them out. Right? We're going to store them in local variables and then print out the two of them. So if we called it with hello 23, it's going to print out you passed hello, 23. Return values are where things start to get a little different. Again, the general idea is that return, as far as Bash is concerned, is dealing with the exit status of a command or a program. So same idea with a function. It's meant to represent an exit status, a return status. So this is going to be a single byte, a single integer value in the range 0 to 255. If you return anything else, it's going to wind up getting chopped off as just a value in the range 0 to 255. So only one byte actually gets returned, and it's going to be interpreted as a single integer byte. So don't think of return values in Bash the way you're used to thinking of return values in functions in other languages. So if we're using the return for the exit status, then we need some other way to get more complex values back to whoever calls us. And the way we do it in Bash is by having the function print out the other information, and whoever calls the function captures the function's output and then has to go through and interpret that. So this can be used to effectively quote-unquote return all sorts of values, but it does mean that any text that your function outputs has to be accounted for by whoever called it as well. Right? Whoever calls the function has to know what kind of output to expect. All right, the way we actually capture it, I think we've mentioned this before, is using the dollar and round brackets. So if I've got some function square, and I think this is just supposed to assume it's being given an integer and it's going to compute the square of it and print it out, right? So we're computing the square, printing it out, and then whoever calls this is going to capture the output from this function call. So we'll call function square, pass it 205 or some other integer, use the dollar round brackets to capture the output and store it in a variable, and then we can print the value of the variable. The square of 205 is whatever it is. And so again, this is very different than the way we handle, if you like, the real return values in other languages. A handful of special variables. Again, we mentioned $1, $2, $3, etc. $0 is the name of the function. So again, it's kind of like argv0 if you're thinking of the command line arguments in C. You can figure out how many parameters were actually passed by the variable $, and then the pound sign. $at gives you the entire list of arguments as an array of strings. $* gives you the list of arguments as one big string. So so that it looks the way it would if when the user actually typed in something like this. And again, the $? gives you the exit status of the function after it ran. All right. Just as an example to take all of the parameters that somebody passed and just iterate through them. Here's the arguments you passed. So we'll set up a counter to keep track of which argument we're on, and we'll say for arg_in the array of arguments that were passed, print out arg_i, or arg0 or arg1 or arg2 or whatever is $arg. And again, this is going through the contents of the array of arguments, and we're just using this to increment the little counter so we can tell them what position we're on. And so this is one way to iterate through all of the parameters that were passed. So if we're calling it, if you just pass a bunch of different words, 10, 20, 30 or something like that, then each of them is going to go in as one argument. If you enclose some of them in the round brackets or the double brackets or the single double quotes or single quotes, then that is treated as a single argument. So in this case, 10 would be the first argument. The string 20 space 30 would be the second. The string 40 would be the third. So just something to keep in mind when you're dealing with this is everything we're dealing with are strings. Now, the function has no idea how many parameters are really going to get passed, and it has no idea what kinds of values those parameters are going to have, right? Everything's a string, so if we're expecting an integer or we're expecting something that we can treat as a float or we're expecting whatever, we have to go through and check for that in the function. So at the very least, functions should go through and check that the user actually passed the right number of parameters. And depending on what you're doing with them, you might need to check that they were actually the correct data types as well. So checking the number is easy, right? Just the $hash and is it in the right range or not. Checking the data types is trickier because all we're getting passed are strings. So we have to see if the string looks like it's got the right pattern, if you like, for what we were expecting. Right? If we were expecting an integer, we can take a look at it and say, okay, well, is it all digits, or maybe digits and a plus or a minus sign in front? If that's the case, then yeah, okay, we'll treat it as an integer. If not, then something went wrong. So what we'll do in the near future is to start looking at regular expressions and pattern matching to say, okay, well, I'm expecting a parameter that looks kind of like blah, a parameter that looks like a date, or a parameter that looks like a file name, or a parameter that looks like a float. And so we'll start building up these patterns to check if the input parameters we were passed look like they're valid. But we'll come back and treat that as a special topic all on its own. All right, we can call the functions from within our script, as we've seen, just using the function name and all of the values that we want to pass to it. But it might be kind of handy, right? Since Bash is meant to help us in our day-to-day user lives in Linux, it might be kind of handy if we could put a function in a file and then call that function from the command line whenever we wanted to. Right? If we came up with some really useful function and I just wanted to be able to, sit at my terminal and run that function anytime I wanted, that would be really handy. So there's a command called source that basically loads the definitions in a file. So if I have a bunch of functions in my mystuff.sh, I can say source mystuff.sh, and assuming there's no syntax errors in the file, this will go through and load all of those definitions, and then anytime after that, from the command line, I can run any of the functions that were defined in there. So if there was a function f, I can just say f and pass it a bunch of parameters, and it will run that function. Now, if we edit the file, then we need to run source again to basically update the definitions that we're using, but we can go through and do this quite happily. Now, I could get into the habit every time I log in to source the file that's got all my interesting definitions in it, but we can also automate that a little bit, and we can put that line, source mystuff.sh, into a file that automatically gets run every time we log in, our .bashrc. So we'll talk about this when we talk about customizing our Linux accounts pretty soon, probably next time around. But yeah, we can set this up so that this gets automatically sourced every time I log in. So from that day forward, anytime I log in, I can use any of the functions. I can call any of these functions from the command line anytime I want. So, assuming that they're actually not buggy and so that this doesn't crash while it's running our bashrc. But we'll get into the gory details of that pretty soon. So this is the beginning of the point where we can really start using bash to make our lives more pleasant, where we can start writing code that we can use on a regular basis and putting it somewhere where it will automatically be available for us. So we'll pick up with some of this stuff next time around, but I guess first we should play a little bit with some of this in code. Let's see, what did I call this one? Funcs.sh? How about maybe just func? Right, okay, so just looking at a few simple file examples, or function examples, to play with this kind of a concept. So we've got a file check function that expects to be passed the name of a file as a parameter. So the first thing we'll do is check and see if we were actually passed a valid number of parameters. Is there at least one parameter? So again, the $hash tells us how many parameters were passed. So if it's less than 1, things didn't go well. We're going to return an exit status of 1. So I'm going to use return value of 0 to mean things went okay. A return value of 1 means things went wrong. So if we got a return value of 1, then we'll check that first parameter. So we'll store it in a local variable and check if it's actually a readable, writable file. If it is, then we'll run the bash command ls-l and the file name to just print out the data on that file. So that's essentially what this function is going to do if everything is going okay. It'll print out the ls-l information on the file and return 0 to indicate everything worked. If the file didn't exist or it wasn't readable, then we jump down to the else case and again return a 1, return an exit status of 1. So this function returns an exit status of 1 if anything goes wrong, wrong number of parameters, well, basically no file name or invalid file name, it returns a 1. If it was given the name of a file that does actually exist, we're printing out the information and returning 0. So that gets us to use the return values and the output, right? This ls-l is just going straight to output. So then we'll have maybe a little main routine to go through. Well, actually, no, let's just try that source command that we were talking about, source func.sh. And it's going to actually go through and run this for us. Enter a file name, foo, no fi, invalid, no file specified. Okay, so I believe that now having run or having sourced my file, I can actually run my file check function from the command line. File check foo. What did I do here? Less func.sh. So it's echoing the parameter. Oh, okay, right. So it was, this actually wound up returning a 1 because foo doesn't exist. Okay, so we can actually run this from the command line. Let's run file check and actually give it the name of a file that exists and is readable. And it runs the function, gives us the ls-l output from it. Right, so we can go through, stick functions into a file, and use them from the command line anytime we want. So let's go back and take a look at that second function in here. So one of the things that can be handy is when you're writing a script to effectively put a main routine in the script that's going to be, okay, this is the stuff that, this is, if you like, the central coordinate. Hey, you got the idea from C++ mains, right, where we're going to go through and say, this is what's going to be the main body of whatever the script is supposed to do. So in this case, the main routine is going to get the user to enter a file name. If they didn't enter something, then it's going to call the function and pass it no parameters. If they enter an actual file name, we'll pass it to the function. We'll capture the status value. If the status value is good, we'll display the results. If the status value is bad, then we'll say, no, that wasn't, the file check said something went wrong. So again, here we're going through capturing the output that file check produces one way or the other, and capturing the exit status using the $question mark. So the main routine is going to go through, get some, potentially a file name from the user, run the function, and tell us what went on. And then at the bottom of our script, we'll just actually run that main routine. So if we give that a try, so we'll run our func.sh, it'll ask us to enter a file name. If I don't enter anything, again, it's going to call file check without a parameter, and we get the result that we wanted. If we run it and I type in, again, foo, it's going to run it, and again, it detects the error. If we give it something valid, then the file check actually displays the ls-l information that gets captured in the main routine and displayed by the main routine. So, all right, so again, in the main routine, we captured the output from the function call, and then if everything went okay, we displayed it. And again, if the return status was bad, then we just displayed this stock error message. All right, so you can go through and start calling functions, seeing if they returned a good exit status or not, capturing their output and doing things with the output they produce. All right, that is probably a good place to leave that for now. We'll get into lots more examples as time goes on.